So what is an exponent? It simply means we have a number that's repeating itself in multiples. So what do I mean by that? If I have 2 times 2 times 2 times 2, I don't want to write that, in that way. Sure, we can write it as 16. Nothing wrong with that. But we're trying to understand exponents. So that would equal to 2. The number of times we multiply 2 to itself. So first time, second, third, fourth. So we have 2 raised 4. So it's the power, and that's the base, and that's what we call an exponent. Instead of 2, if I had a times a times a times a times a, we have a in common. 1, 2, 3, 4, 5, a raised 5. So keep in mind, if you multiply a number to itself as that number of times, that would just equal to the number raised to the number of times you multiply to itself, including the first one. So here we have some properties of exponents. Suppose I multiply x raised to the power of m to x raised to the power of n. Since the bases are the same, I could put that common base and add the powers m plus n. You can only do this if they have the common base, which in this case is x. If x is not 0, x raised 0 is 1. Any number raised to the power of 0 is 1, except the number 0. It could be positive or negative, doesn't matter. If we have x raised m divided by x raised n, those two match up. So I'm just going to put x and write it as m minus n. If I have x raised m and raise it to the power of n, we will simply multiply those two. So x raised m times n. Another important case is when you have different bases but identical powers. So the x and y are different numbers. So I should probably write that x is not equal to y. So this part is different from part A, or property A. But if you look at it, they have the same power, unlike the first property, where one was m, the other was n. So case A, I could write it as same base, different exponents. Here we have different bases, same exponent. If we have something like this, we can bump x and y together and then raise it to the common power m. The same applies to x raised m divided by y raised m. The powers are identical, the bases are different, so I'll have x over y raised m. This is different from part C, where we had identical bases, or should I say same bases. So same base, different exponents. Different bases, same exponents. So if we understand the properties really well, then we can solve any exponent problem easily. So some like to call rule C and D, excuse me, C and F are called quotient rules. Rules A and E are called product rules. Rule D is called the power rule. Before we move to the example, I guess I'll write this rule now. So if I have x raised m, it is the same as saying 1 over x raised negative m. Likewise, if I have 1 over x raised negative m, it is the same as saying x raised m. If I have 1 over x raised m, I will have x raised negative m. The easier way to remember this is x raised m can be written as x raised m over 1. So anytime you move exponent from the numerator to denominator, the power will change in sign. So when that entire x raised m moves to the denominator, we end up getting x raised negative m. In a similar manner, if we move from the denominator to the numerator, the power will change sign. So x raised m would now become x raised negative m. So we want to write each expression that is given to you in positive exponents only. So here is the first example. So I have x raised negative 1 and y raised negative 2. So multiplied by 5, of course. So I could write it as 5 times x raised negative 1, y raised negative 2, divide the entire thing by 1. It is the same thing. Then we could use rule G. At the beginning, when you're learning, it's best to do it one term at a time. Once you have enough practice, you can do this simultaneously. So first, I'm going to move y raised negative 2 from the numerator to the denominator. So it would become y raised positive 2. Then I'm going to move x raised negative 1 from the numerator to the denominator. It would become x raised positive 1. Any number raised to the power of 1 is the same number itself. So I could write it as x times y squared. And now the expression has only positive exponents. So 8a cubed, b raised negative 2, c raised negative 4. We want to write this in positive exponents. So first step to start is to visualize a denominator. Denominator is 1. Move c raised negative 4 from the numerator to the denominator. C raised negative 4 would now become c raised positive 4. Move b raised negative 2 from the numerator to the denominator. You will have a raised negative 3 divided by c raised 4 multiplied by b squared. So we have 2, a raised negative 5, b raised negative 4, c divided by 1. You don't have to do that intermediate step. I'm doing that so that you can learn, but once you have enough practice, you don't have to do that. So I'm going to keep 2c in the numerator and try and move, or not try, move a, b terms to the denominator. B raised negative 4, if it moves to the denominator, it becomes b raised positive 4. A raised negative 5, if it moves to the denominator, it would become a raised positive 5. And that is our final answer. So now we have negative in the numerator, negative in the denominator also, and then we've got another variable y. This is no different than the previous problem in the sense, instead of moving in one direction, numerator to denominator, now we're going to go in both directions. Move all the negative exponents from the numerator to the denominator. Move all the negative exponents in the denominator to the numerator. So that's going to move down. So we will have y divided by x raised 5 t raised minus 3. That's going to move up. Y t raised 3 divided by x raised 5. So the previous problems we did was one of the rules was rule G, but now we're going to use the quotient rule to simplify expressions, and we are able to simplify here because the base in the numerator, the base in the denominator are one and the same. Some look at this and immediately get spooked because there are a lot of things going on. If it is too difficult for you to see it right away, you can always use parentheses to make things clear. So the 8 and the 2 will get cancelled. So we will have -2 x raised 5 over x squared. The quotient rule says if the bases are identical, x, then we subtract the powers. So 2x raised numerator power minus denominator power. So we have -2x cubed. Another example. So we have 27a cubed, b cubed, c squared divided by 3ab squared. If you can solve this directly, that's fine. If not, you can take the parentheses approach. Another way is to split the fractions using the bases. What do I mean by that? I could write number over number, 27 over 3. The a terms, a cubed over a. The b terms, b cubed over b squared. The c term, c squared over 1. We can cancel. Nine, the a and the cube would get cancelled. So we have a squared, or the quotient rule, sorry. See, that's my habit. So the bases are identical. So we would simply subtract the powers. Numerator power minus the denominator power. So 3 minus 1 multiplied by b. Since the bases are identical, you would have numerator power minus denominator power. The last term is just c squared over 1, which is just c squared. So I would have 9a squared b c squared. And that is our final answer. So here we have 14a raised 5 b squared c raised 4 divided by 2a squared b c squared. So 14 over 2, the numbers as one fraction. I'm able to split them right away because they are in product. If there are any plus signs, minus signs in the numerator, plus signs, minus signs in the denominator, we can't simply split them and write them like we did in the previous problem and like I'm about to do now. So a raised 5 over a squared, b squared over b, c raised 4 over c squared. Two goes into 14 7 times, so 7. the bases are identical. So A, subtract the powers, numerator power minus denominator power, multiplied by B. Bases are identical. So we have B, numerator power minus denominator power. Bases are identical. C, numerator power minus denominator power, 4 minus 2. So we have 7. A raised 5 minus 2 is 3. B raised 2 minus 1 is 1. But B raised 1 is just B. C raised 4 minus 2 is 2. So the answer is 7a cubed b c squared. So numbers together, so 25 over 1, a cubed over a, b raised 7 over b, c raised 4 over c squared. 25, a cubed over a, same base, 3 minus 1, b raised 7 over b, identical base, b raised 7 minus 1, c over 4 over c squared, identical base, numerator power 4 minus denominator power 2. So we have 25 a squared, b raised 6, c raised 4. So here is a different type. Let's say we have 6 a squared raised 4 b squared over ab. And we want to simplify this. The very first step is to take note of that. And we can make use of the power rule to simplify that term. So 6 a squared raised 4. If we have power raised to another power, we just multiply the powers. So we have a raised 2 times 4, I get 8. B squared divided by a multiplied by b. Now we split the terms, 6 over 1 times a raised 8 over a times b squared over b. Well, 6 over 1 is just 6. A raised 8 over a, identical base, so a raised 8 minus 1. B squared over b, identical base, b raised 2 minus 1. So we have 6. A raised 8 minus 1 is 7. B raised 2 minus 1 is b raised 1, which is the same as b. X squared y raised 4 divided by xy, x y squared raised 2. So the very first step here is to recognize or split the fractions 12 over 1 multiplied by x squared over x multiplied by y raised 4 divided by y squared, and you square that again. So we simply have to multiply the powers. y raised 2 times 2, we get 4. Those two will get cancelled because they are the same term. So 12 over 1 is 12. Identical base, x squared over x. So we have x. Move the 1 to the numerator power minus the denominator power. So we have 12x raised 1, which is simply 12x. So 3 over 1, x raised negative 9 over x raised negative 5, x raised 4 over y. So 3 over 1, bases are identical. So we move to the numerator, negative 9 plus 5. Numerator power minus the denominator power. Let me not skip a step. So numerator power is negative 9, so minus of minus 5 times x raised 4 divided by y. So 3 over 1 times x raised negative 9 plus 5 over 1 times x raised 4 over y. I could have had that over 1 there also. So 3 over 1, x raised negative 9 plus 5 is negative 4 over 1 multiplied by x raised 4 over 1. So in the numerator, we have 3 multiplied by x raised negative 4 multiplied by x raised positive 4 divided by 1 times y is just y. So 3x raised, since we are multiplying and the bases are identical, we have x raised minus 4 plus 4 divided by y, which is 3x raised 0 over y. Any number raised to the power of 0 is 1. So 3 times 1 over y, which is 3 divided by y. So we want to write it in positive exponents after simplifying. A couple of ways to do it. So first, I'll take care of the numerator. So those two are identical and we are multiplying. So y raised negative 7 plus 1, adding the powers because we are multiplying, divided by y raised 8. Y negative 7 plus 1 is negative 6, divided by y raised 8. We want positive exponents, so we're going to move y raised 6 to the denominator, y raised negative 6 to the denominator. So 1 over y raised 8 times y raised positive 6. 1 over, those are identical, so y raised 8 plus 6, we will get y raised 14. So split up the numbers, 18 over 3 times a over a raised negative 3. I'm splitting up the a's and the b's also. B raised negative 6 over b raised positive 6. 18 over 3 is 6. I'll write it as 6 over 1. Multiplied by a, we're going to move a raised negative 3 to the numerator. So we will have a multiplied by a raised positive 3 divided by 1. We are going to move b raised negative 6 to the denominator. So we will have 1 divided by b raised 6 multiplied by b raised 6. So 6 over 1 multiplied by a times, well, the bases are identical. Add the powers, a raised 3 plus 1. 1 over b and b identical. So b raised 6 plus 6. So 6 over 1 times a raised 4 over 1 over b raised 6 plus 6 is 12. So we will get 6 times a raised 4 times 1, 6a raised 4 over b raised 12.